Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, Southern Research, solving the world's hardest problems, the Holly Family Foundation, Alabama Works, Alabama STEM Council, Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, Alabama Math, Science, and Technology Initiative.
I love chocolate chip cookies, don't you? But they kind of make my mouth dry. The perfect drink for chocolate chip cookies is chocolate milk. That's about enough, right? 1, 2. It's like there's a tornado in my chocolate milk. I know someone who can explain what this milk chocolate tornado is all about. Come on. And welcome to our newest episode of Alabama STEM Explorers. I'm Anderson.
And I'm Kathryn.
And today we're coming to you from Southern Research in Birmingham, Alabama. I was just telling Kathryn about how when I was stirring my chocolate milk, there was a tornado inside of it.
So what you saw was actually a vortex, which is really exactly what a tornado is.
So there was a tornado inside my chocolate milk?
Well, not quite, but let me ask you this. Have you ever been taking a bath and unplugged the drain and then watched a whirlpool form in the bathtub as that water drained out?
Yeah, I used to be afraid that I would get sucked up inside of the drain.
You know what, Anderson, believe it or not, I used to be scared of the exact same thing. And so if you've ever watched the water drain from a bathtub, you have seen a vortex. And a vortex is a type of motion that causes liquids and gases to travel around a center line in the form of a vortex.
I don't know if I understand very well.
Yeah, have you ever heard a tornado siren before?
Yeah, they're really loud.
Yeah, and they're loud to give you as much time as possible to prepare for what might be coming.
Oh, I see now.
Yeah, and here in Alabama, we live in what's called Dixie Alley, and it's called that because we have tornadoes coming our way almost every year.
That's kind of scary to think about.
Yeah, it is a little scary, but that's okay. As long as you are prepared, you will be okay. But tornadoes don't just pop into existence, they develop out of thunderstorms. So when there's already a steady upward flow of warm, low pressure air to get things started. And so think about it like this. Do you like popcorn?
Yeah.
Yeah, I love popcorn. So when you put a bag of popcorn into the microwave, there's no popping the first few minutes, right? It's just pretty quiet, but then all of a sudden it's like pop, 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 pop. And so just like a tornado developing out of a thunderstorm, in the microwave, the conditions were already there to induce that popping, but it needed that extra time to really get things started. Does that make sense?
Kind of, but I still don't get the whole low pressure, high pressure, warm thing.
Yeah, so when warm and cold air masses meet, a thunderstorm can grow. And I've got a great experiment that can help explain this. So what we have in front of us is we have a tub of lukewarm water. We have a beaker of water, some red and blue food coloring, and an ice tray. And anybody can do this at home, and it's pretty cool. We are going to simulate a thunderstorm in a box. So the first thing that we're going to do is I'm going to go ahead and drop some blue food coloring into our water. And you want to give that a stir for me?
Oh, yeah.
Perfect.
This looks like my favorite color.
Yeah, it is very pretty. It kind of matches our shirts. And so now what you can do is you can fill this ice tray with our blue water.
Okay.
Because we want blue ice cubes in this experiment. Perfect. Just like that. You're doing a great job. Yes. And now, Anderson, once you get that filled up, will you go pop it in the freezer for me?
Of course.
All right.
All right, my ice cubes are ready.
Sweet. Okay, so we are ready to do our experiment. So what we have in front of us is our stable atmosphere. And in this experiment, Anderson, what we're going to do is I would like you to add these blue ice cubes to this side of the bin. I am going to add the red food coloring to this side of the bin. Because when unusually warm air near the land surface rises and unusually cold air from the upper atmosphere falls, or oftentimes both, those currents are going to start to churn really rapidly. And so we will be able to see this in our experiment. So would you like to go ahead and drop some ice cubes in there?
Okay.
So the blue is going to represent the cool or the cold air sinking, and the red will represent the warm air rising.
Okay. Oh, these ice cubes are freezing.
I know, I bet they are. Keep on going. All right, good deal. All right, so we will watch.
Good.
We can add a few more, or you can probably start to see it. So whenever these two air masses meet, you will start to see them sort of they'll sort of go over and under each other. And an example of this in our daily lives is sort of how steam rises in the shower. And this happens because of convection. And this type of energy can lead to thunderstorms, just like we see here in Alabama.
Wow, that's really cool.
Yeah, oh, this is really neat. So you can really see the warm air rising and the cool air sinking. This is pretty cool. This is a good one.
Just like how the ocean currents form.
That's exactly right. But now we can model a tornado because the environment, the conditions, everything is right to induce a tornado. All right, Anderson, now that we know how thunderstorms are created, how would you like to make a tornado right here in the lab?
As long as it's safe.
Don't worry, it'll be just a small one. But first, I want to show you a trick, and you guys can do this at home. So first thing we're going to do is we're going to fill this bottle up with water. Oop. It's a little wet. All right, and I want to see how fast can you get this water out of the bottle. You cannot squeeze the bottle, all right? And go.
This is going pretty slow.
Pretty slow, yeah. You're pretty slow. Okay, that took like 13 seconds for you to get all of that water out of the bottle. And now we're gonna do it one more time and we're gonna have a race, all right? And I'm gonna show you a little trick to show you how to get the water out of the bottle a little bit faster. Oh. All right, so I have a bottle of water.
That looks a little uneven.
Yeah, it does look a little uneven. Yeah, we're gonna be fair. There we go. It is pretty even. All right.
Okay.
So we are going to have a race. I'm gonna see how fast I can get this water out. You're gonna see how fast you can get this water out. All right.
I'm totally gonna win.
All right. Whenever I say go, not yet. Are you ready? On your mark, get set, go. Waiting on you, Anderson. I'm waiting.
Hey, that's cheating.
It's cheating, no. So what I just did was I made a little bit of a tornado in a bottle. And so as Anderson was doing it, I mean, you could see the water goes in, the air goes out. The water goes in, the air goes out. But whenever I made a vortex, then that air could just, it could go straight up the center of the bottle while the water flowed from the outside. It makes it go a little bit faster. And that vortex, same thing as a tornado. So are you ready to make our tornado in a bottle?
Oh, yes, definitely.
All right, so I'm going to move this stuff out of the way. And here's some containers for you. We have 3. We're gonna make some pretty tornadoes, all right? So the first thing I want you to do, so this is just water in a bottle, and we could use these, but what we're gonna do is we're gonna add some lamp oil. So if you wanna take that, I will hold the funnel for you, and the lamp oil will help us see our tornado just a little bit better. Great job. Ooh, I love that blue. That blue is really pretty. All right, perfect. And we are also gonna, what color do you like the best? Red or yellow?
Yellow.
Yellow, all right. We will also make a yellow one. Go ahead and pour it in.
The water gets a little jumpy.
It does get a little jumpy. Okay, perfect. Now, what do you usually see in a tornado?
Debris.
Debris, exactly. So we have some debris over here, so we can go ahead and add, we have some beads, so you want to add those beads to the funnel, and then we'll even, yeah, there you go, perfect.
Woo, that's so cool.
Yeah, it is cool. And here's some glitter, if you'd like to add some glitter. Ooh, I like this gold glitter too. Oh yeah, oh sure, just dump it all in.
Dun, dun, dun. Glitter, glitter, glitter.
Glitter! Perfect, and then we need to add a little bit of glitter for our blue tornado, right? So
Of course.
Yeah.
Can't leave the blue out.
Now, if you're doing this at home, you do not need to add glitter and lamp oil to your tornado, but I like to jazz things up. So science does not have to be all business all the time. You can have a little fun with it, and glitter makes everything more fun. Absolutely. Don't you agree? Here,
Definitely.
you can add this one. I'll add this one. There we go. Oh, and we need our beads. So, all right. Perfect. Now our conditions are ripe for the tornado, and I love this little toy. So anybody can buy this online or at a little science shop, but it's just a plastic connector, and it's going to connect two of our bottles like this. And then do you want to screw this bottle in the top of our blue one?
Sure.
And if you don't have one of these plastic connectors, you can really make this out of a PVC pipe and a washer, and it'll do the same job. Perfect.
That looks good.
It does look good. All right, and so the way that we are going to make our tornado in a bottle is we are just going to flip this over, and then you're gonna start spinning it to create that vortex. Are you ready?
Yeah.
All right, here we go. We're gonna spin.
Whoa.
Good, your tornado is so much better than mine.
Cool.
Look at your tornado go. Oh, there it goes. Look at that. And so you can see the debris or the glitter and the beads, and that represents the debris. And maybe something that would be fun that you could try, maybe throw some Monopoly houses in there or something. And then you can really see it. You can really see it spinning. And I've made a few other ones that we can kind of play with. I love this red one. Go ahead and spin that around. I'm going to try this. This yellow one is really, really cool. There we go. So this is sort of how a tornado will form, because you have that centripetal force going, and that is helping that spiral motion and this come to the bottom. Perfect. So this is kind of how tornadoes are formed, and you can play with these all day long. It's a lot of fun. Anybody can do this at home, but are you starting to understand how tornadoes are formed?
I think so, but I'm still a little confused.
Well, you are in luck. My good friend, best friend, James Spann, he has all the answers. And we're gonna go pay him a visit at McWane Science Center. You ready?
Yes!
All right.
I've loved weather ever since I was a little boy. I would love storms. I would love just rainy days, anything related to weather. And I'll never forget in first grade, I got in trouble one day. I was a window starer guy. I stared out the window constantly. And one day, my first grade teacher, Edna Earl Porterfield, she had enough. She said, "Spann, get out here now." And I'm thinking, uh-oh. But I didn't get in trouble. She smiled and she gave me a little book about weather, about clouds, and I read that book over and over and over. And that little book in first grade started me on a journey I'm still on today, learning about weather. It's really fascinating to me to look back on my life and to see the encouragers I had, people that encouraged me to learn about science, the science behind weather. It really started with some math teachers back in middle school. They said, you know, solving a weather forecast, it's like a math problem in a way. They taught me analytical thinking. And as I got older, a Weather Service employee, National Weather Service employee, J.B. Elliott, took me under his wings. And he taught me about weather. He taught me so many things to this day. I'm thankful for the lessons that he taught. And he was willing to spend time with the young person to teach them about weather and to encourage them to ultimately get into it. And because of people like J.B. Elliott, I'm here today.
Hi, my name is Reginald, and I was wondering what causes fog.
What a great question. Fog is a natural phenomenon that happens when cold air affects the water in the air. Fog is made up of a million tiny water droplets suspended in the air. Fog comes out of air where there are always water molecules zipping around, donated from rivers, lakes, oceans, and plants. Warm air can hold a lot of water vapor. But as that air cools, it reaches saturation like an overfull sponge about to drip. That excess water suddenly condenses into visible droplets and shapes itself into drops by attaching to particles of dirt, dust, and pollution. Droplets grow bigger as more and more water molecules collect together, forming a light haze that can thicken into a dense fog.
Hi, and welcome back. We're coming to you from the McWane Science Center in Birmingham, Alabama.
And we are so excited to be in such a cool place and learn about some cool science. So, Anderson, I promised you that I had a very special guest coming today. Do you remember?
Yeah.
Kathryn, my best friend.
Hey, Spann
Yes.
the man, how's
Yeah,
it going?
It's great. It's great to see you guys. I
Yeah.
love the McWane Center, and I love this. I mean, this is rocking right here. This is good stuff.
For sure. And Anderson, you had a question for him, right?
I was kind of confused about the low pressure, high pressure leading to a tornado.
Here's the basic idea. With high pressure, air is sinking. In advance of low pressure, air is rising. And in order for storms to form, you have to have rising air motion. So in advance of a low pressure center, that's when thunderstorms can form. And by the way, you cannot have a tornado without a thunderstorm. Now, sometimes people see swirling dust as they drive by on a clear day. That's not a tornado, that's called a dust devil, which is a ground-based vortex. So a tornado has to come from a thunderstorm, okay, like this. Now, let's talk about storms for just a minute. A thunderstorm is a process called, it starts with a C. Anderson, you're a smart guy.
Convection.
Convection, you got it, okay? So within a thunderstorm, warm air currents are going up. The air gets cold and the air goes down. You have an updraft and you have a downdraft, okay? So within that thunderstorm, sometimes the updraft can begin to spin if the winds are in the right position. The winds down at the surface have to be out of the southeast. In the top part, the winds have to be out of the west. They can set that entire updraft into motion. And if the lower levels are proper, then you might actually see that drop down to the ground, which becomes a tornado. Now, a tornado aloft is called a funnel cloud. The minute it touches the ground, it's called a tornado. Now, I've got good news about tornadoes. Do you want good news?
We would love some good news.
Yeah.
Tornadoes don't happen a lot. I mean, they don't happen a lot. For example, on this day, Anderson, you didn't see a tornado outside. You know why?
Why?
We didn't have one. We didn't have one yesterday. You know why?
Why?
We didn't have one. You might live to be as old as me and you'll never see one. Most storms don't produce tornadoes, but every once in a while they can, and all you have to do is understand them, know what to do, and we'll be fine. Never be afraid of a tornado. It's like a fire. I'm not afraid of a fire. I know what to do. Stop, drop, and roll.
That's
same
right,
Same
yeah.
thing for tornadoes, but you need to understand them, okay?
Okay.
Wow, this was super helpful. And you know, Anderson, we were also talking about the difference between hurricanes and tornadoes, and McWane has an awesome hurricane exhibit. What do you say? Do you want to go check it out?
Yeah.
Let's go.
Hi guys, and we've made it back to the hurricane exhibit where we are now gonna hop on in, me and Kathryn. But we don't want you to go in there because we don't want you to mess up your hair.
My hair could be totally fouled up in this, so why don't you two get in here and let me talk about hurricanes for just a minute, okay? Now, this is going to be fun to watch these guys in a hurricane, all right? So here's the deal. Tornadoes are small, hurricanes are big. Hurricanes are born over the ocean. So if you live in a town that is inland, hurricanes are not born where you are, but they can move inland and create damage. Now, this is wild right here, okay? Notice the wind velocity increasing, 45 miles an hour. Hurricanes have winds of 74 miles per hour or higher. They can range up to 150 miles an hour or higher. They can create damage almost like a tornado, but the main damage caused by hurricanes, not the wind, but the storm surge. A hurricane pushes a wall of water inland, and that storm surge can create major damage, and that surge can be 15, maybe even 18 feet in some cases. The hurricane scale runs from 1 to 5, the Saffir-Simpson scale. The weakest hurricane, a 1, the biggest, a category 5, and I think we can clearly say our two friends here have been in probably maybe a category 1 or 2. Wow, so hurricane season is in the summer. You have to have warm ocean water for hurricanes to form. We never have hurricanes in the dead of winter because the water is too cold. So for the Atlantic Basin and the Gulf of Mexico, hurricane season technically begins on June 1st. Sometimes we have a preseason system in May, but the really core segment of the season comes in August and September. That's when the water is warm, and that's when conditions favor their development. So guys, how was it?
Well, it messed up our
It
hair.
was fun.
Yeah.
I don't have any sympathy for them at all for some reason. I don't know. So now you know what it's like being in a hurricane. And for hurricanes, when it comes to safety, the most important thing is to listen to your local government officials. If you live in an evacuation zone, get out, because you don't want to deal with that, do you?
No way. No, absolutely not.
So if you're told to evacuate, listen to the authorities and leave. All the evacuation routes are clearly marked, and that's awfully important. Hurricane watches and warnings are issued, much like we do for tornadoes. Okay, so pay attention to those. They're coming from the National Hurricane Center, which is down in the Miami area. So always, always understand hurricanes, know what to do, and we'll be fine. And leave if you're told to leave, because you don't want to look like that.
She does look crazy.
So, we've learned about hurricanes, we've learned about tornadoes, but a meteorologist has to communicate the danger to the public. And the best way to do that still today, it's television. So it's time, Anderson and Kathryn, for you two to become an on-screen meteorologist. So this is the way we do it. You've already learned the secret because we're standing here. We stand in front of a what?
Green screen.
Green screen, okay? And then I think most people know that. If you ever watch us on television, there's nothing back there but a green wall or a green screen. Here's the trick. Whatever that color happens to be will disappear and turn into weather maps or whatever we want it to be. And in my hand, I have a little clicker that changes the pictures back here. But there's one important thing. You cannot wear green, because if you wear green of this color, guess what happens? You disappear. You become a weather map, which is slightly weird. So now here's how you do it, okay? So again, if you're watching at home, they don't see the green, they see maps. All right, Anderson, turn around, look at that. What do you see?
A green wall.
A green wall. That's not going to help you if you're on television, because you have to point out the location of a thunderstorm, of a tornado, or a flood. So how in the world do you see what's back there? We have a little mechanism here, a little cheat sheet, if you will, a little monitor. So what you're going to do is actually look in this monitor right here. So you turn around as though you're looking back here, but your eyes are right here, so you can see what's behind you. And that's how we do the weather on television, okay? Now, the other thing we have to talk about is safety, because we tell people a tornado's coming. What do? Okay, well, the first thing, you have to be able to get the message. You have to be able to hear the message. The message we use when a tornado is down is called a tornado warning, okay? A watch means conditions are favorable. A warning means it's happening. And you've got to be able to hear the message. And most people think they're going to hear a siren. No, you won't. Never, ever rely on a siren. You can't hear them during a raging storm. You can't hear them at 3 in the morning. You can't hear them in a business or a cool place like the McWane Center. You have to have a weather radio in your house. Weather radio. It's like a smoke alarm for a tornado in your house. They're marvelous. And once you get the warning, you got to go to a safe place. You've got to have a plan. Small room. Everybody's got one. Hall, closet, bathroom. You have one of those?
Oh, yeah.
I know you do. You've got to be near the center of the house, lowest floor, and away from windows. And one more thing. Everybody, Kenny, has to have a helmet, okay? Most people that are seriously injured in tornadoes are injured by blunt force trauma to the skull region or the neck region. And by putting on a simple bicycle helmet, a batting helmet if you play sports, that really reduces your chance of being seriously injured by a tornado, okay? You got it? It's easy. And this is for everybody, not just kids. It's for adults. Everybody, every life is precious. So get the warning, have a plan, know your safe place, and put on a
helmet.
Yeah. Now, I'll say it looks good on YouTube. For me, when I put on a helmet, it looks like kind of lipstick on a hog. It's not a good look, all right? But you guys look good. But most importantly, you got to do one thing when it comes to tornadoes. One thing. You ready?
Respect the polygon.
If you missed anything or you want to watch something again, you can check out our website at alabamastemexplorers.org. Maybe you have a STEM question we could answer here on the show, and you might grab a cool t-shirt. Feel free to send us a video question or an email on our website, alabamastemexplorers.org. Thanks again for watching. We'll be back next week. Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, translating the power of genomics into real-world results. Southern Research, solving the world's hardest problems. The Hawley Family Foundation, established to honor the legacy of Brigadier General Everett Hawley and his parents, Evelyn and Fred Hawley, champions of servant leadership. Alabama Works, a network of interconnected providers connecting business and industry needs to a highly skilled and trained workforce. Alabama STEM Council, dedicated to improving STEM education, career awareness, and workforce development across Alabama. Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, advocating for exceptional STEM education in Alabama. Alabama Math, Science, and Technology Initiative, the Alabama Department of Education's initiative to improve math and science teaching statewide.